which is Service Solutions and Air Quality Control Systems. And in this session, we'll hear from Mr. Atul Agarwal from GE. Mr. Agarwal, I request you to please turn on your video. Welcome to the conference, sir.
Yeah, thank you.
I'll briefly introduce you to the delegates first, and then we'll start with your presentation. Mr. Agarwal is AQCS Service Product Leader, Clean Combustion India at GE. He is presently in charge of service product for air quality control systems and is involved in acquiring and execution of service project for industries and utilities. He possesses domain experience in various functions like field inspection, testing, troubleshooting, tendering, process application, performance improvement solution, etc. Mr. Agarwal is mechanical engineer. Welcome, Mr. Agarwal. We have around 20-25 minutes for a session. First, the presentation, followed by questions from the audience. I will request the audience to please type in the questions while Mr. Agarwal is presenting, and we'll take them at the end of his presentation.
Thank you,
Over
Priyanka.
to you, sir. Thanks, sir.
Thank you. Good afternoon, all the dignitaries, panelists, and all the participants and attendees. I'm Atul Agarwal. During the next 20 minutes, we'll go through a service solution is air quality control system. We'll mostly focus on the particulate matter. The agenda will be the key drivers and challenges we face for particulate matter controls, AQC service solutions, what could be the solutions, as well as refurbishment, upgrade, and retrofit solution for particulate control. Just to tell you, yeah, can G help service and control particulate emission for the installed base? Yes, for the OEM fleets as well as for the other OEM fleets, for the industries and all the power plants. Coming to the key drivers and challenges, as we will be working on the existing fleet, existing installed AQCS equipments, mostly on ESPs and back filters, the key drivers for us is to look at the emission reduction, which is the first driver for the AQCS equipment. So we have to comply with the emission limit norms, as well as for the industries, it's a raw material and production recovery, which means whatever is going out of the chimney for the industries like cement plant, like steel plant, pulp and paper is actually the money which is going out. So it is more important from that perspective to control all the emissions so that the product can be recovered and it can be economical run. However, for the power plants, mostly it remains for the compliance to emission norms. But as a key drivers, we can see on the left hand side, we have various drivers like flexibility for operation of the plants, reliability, availability, maintenance cost, and the predictability so that we get the desired output. When we talk about flexibility, during the course of the plant life, say 20, 25 years or 15 years, there are changes in the fuel. Fuel are switched. Earlier, we used to have the low ash content coal. Today, we have high ash content coal as well as we have sometimes vast coals. And then the resistivity of the ash and changes, which directly impacts the equipment performance. It will be specific to mention here that when the ash content goes high in the coal, of course, the performance of the equipment deteriorates, ESP gives higher emission. Additionally, if we are using a washed coal, then it is more critical to know because when the coal is washed, it actually washes away all the alkali oxides in the coal ash, which are good for the ESP performance. So which means it increases the resistivity of the ash many folds. So maybe the inlet dust concentration to the equipment is less, but the ESP does not perform to the desired performance because it has low uh, alkali oxide like sodium oxide, potassium oxide, as well as iron. On the second point, there are changes on process parameter through the life of the equipment, which means a ESP has been designed or a back filter has been designed for a particular 100 meter cube of gas volume. Wherever during the course of the 15 or 20 years or 10 years, there has been increase in the gas flow due to the reason of coal change, due to the leakages in the system, and then the gas increases. To my experience, it increases by somewhere between 10 to 20%. The gas flow increases, which means it increases the velocity in the ducting. In the ESP, it decreases the residence time or treatment time of the equipment of the dust particles, which increases the emission. Secondly, the temperature increases, say initially from 140 to 150 or 160. As we know that as the temperature increases, the resistivity goes high for the fly ash, and which increases the emission. Third is today many times we need to operate the equipment in a low load operation or flexible operation, but there are certain challenges associated with the low load operation, that when the gas flow is low, there could be dust deposition or dropout in the ducting, or if we have to smartly bypass some of the passes of the equipment so that we can still manage the dust depositions, and we can operate with the optimal power consumption of the equipment. From the reliability point of view, during the age, during the operation, the internal gets wear and tear. There is poor gas distribution inside the ESP, which might be due to the aging or erosion of the guidewires in the inlet duct, which deteriorates the gas profile at the equipment inlet as well as inside the ESP, and then it deteriorates the performance. Additionally, there could be sneakage below and above the field during the maintenance process, which are left out and that impact the performance directly. Secondly, if the equipment is quite good or healthy, the second one is the lifeline is electrical optimization of the equipment, which means how the power to the ESP is fed, how smartly the power to the equipment is fed so that it can operate with the optimum currents, voltages, as well as wrapping settings so that it can clean the plates. Another one is associated is leakage in the duct and dust bridging the hopper and dust handling system, which must be adequate enough to handle all the dust which are coming with the highest content coals. Predictability, with all the we should be able to predict how the outages are planned for the equipment, what is the today's situation of the equipment, and what we need to do in the next year so that equipment is healthy and operates reliably. So based on these conditions, the main solution what we always propose is from inspection to upgrade. It's not that we need to upgrade the equipment on the first day. What we need to see what we can best take out from the existing equipment, and then we see whether we need to invest in an upgrade plan or not, which starts from the inspection of the equipment within a smart eye inspection, service overall of the equipment. Then we change the spare part whatever we need to make it healthy. Fourth one is gas distribution, which is very important from one perspective, that during the course of operation, there could be deterioration in the guideways in the ducts and baffles on the GD screens, so which can disturb the gas distribution, and that directly impact the performance. So it should be a smart way of checking the gas distribution every few years, say 4 to 5 years, so that things are in order. Then, then when the ESP is mechanically healthy, we should look into how we can optimally charge it with the control system. There are very advanced control system available now, and then we can smartly manage the back corona effect, high resistivity ashes, as well as low resistivity ashes in the various processes. Number seven is performance audit of the ESP. This is quite important because even if the ESP is healthy, equipment is healthy, it might not give the desired emission because the inlet conditions have been changed. Gas flow, temperature, or the dust concentration, as well as the coal characteristics. So if still the desired performance is not achieved, it's wise to go through a performance audit of the ESP, where the technical people can evaluate what are the gaps with respect to design, vis-a-vis present, and what could be the mitigation and solutions. Another important aspect is distribution between the casings. When we talk about gas distribution inside the ESP, we can actually control the distribution inside the ESP from top to bottom. But if the distribution is variable left to right, that can only be corrected inside the duct with the proper guidance and the COD studies. as well as if there are three, four, or five ESP passes or backfilter passes for a boiler, it is more wide. It is, it desires that the distribution between the casing should be plus minus 10%. If it is more, one casing will perform better and one would perform bad, and the overall emission would be higher than the requirement. So that is also, it also need to be checked that the distribution between the casings are equal or within the acceptable range. And the last one, then we can go for a service agreement on maintenance contract for the equipment with the reliable technical people who can really maintain the equipment and maintain the performance through the life of the equipment. Now I will go through the individual service solutions, which will show you that inspection, where we discussed about maintenance, we discussed about gas distribution. One important thing about the gas distribution is we should avoid gas passes through the roof or hopper zone in the equipment, which is a non-treatment zone, and that directly impacts the performance of the equipment. Even if the equipment is healthy with the good current distributions, but it will still not perform. About the control system, controller is the heart of the equipment, and then it has the ability to handle high resistivity ashes to low resistivity ashes, which is a epic controller. To name a few, some of the characteristics are spark control, semi pulse, power control wrapping, and energy optimization. On the right hand side, on the performance audit, we discussed that we should look into the ash analysis, coal analysis, as well as the gaps to find out whether the equipment needs an upgrade or it can very well meet the emission just by the servicing, spare part change, or overhaulings. Some of the reforming solutions for the other OEM ESPs we can propose is change of the emitting electrode from rigid to spirals for the power plants, which can give you uniform corona distribution and improvement performance. Wrapping system, bearing simplification, which actually help you to reduce the maintenance cost and simplicity and reliability. On the right hand side, there is a refurbishment case study. We have done a refurbishment in a Chinese power plant, which is already working for several years. However, it was not able to meet the original design emission, but with the review of the design data and the present operating data, as well as making it mechanically healthy and the epic controller, it could achieve less than the desired emissions. The last one, I will focus on the retrofit upgrade solution for particulate control. If the ESP really needs an upgrade, it cannot maintain the emission due to cold chain, flow chain, or other reasons. There are two solutions, one for mechanical upgrade with the ESP collecting area increase. And however, it has some sensitive or challenges like space constraints, layouts, and proper selection of the input flue gas data and the coal ash composition. On the other hand, if you go to a back filter composition or a combination of ESP and back filter, there are certain advantages that it really needs a less floor space. It gives a positive emission. It is not affected by the change in boiler load or coal flow variations mostly. However, it has a challenge that it has a very high running cost, operational cost, maintenance cost for back change, power consumption of the ID fans, as well as power consumption for the pressure drops and compressor powers. So these are in a nutshell the service solutions. I would now invite for the question and answers from the audience.
Thank you, Mr. Agarwal, for a very informative presentation. And I have received a couple of questions. So I'll just take them one by one.
Sure.
So the first question is regarding the ash collection. So how to ensure
Yeah.
equal and even ash collection in all ash hoppers across same fields?
Okay. I would look this question in two perspective. One is along the gas flow, which means if we have a ESP with say 7 hoppers in 7 consecutive fields, normally as per the principle, the first 2 hoppers collect the most of the ashes, say 90% of ash, and the balance hopper collect very less ash. Say in first hopper will collect say 70% of ash, second hopper 15%, third hopper 5%, fourth hopper 2%, like that. So it is the principle of collection. So we can't change it. because that's how it works. That's how ESP works, because first field has all the coarser and finer particles, so the dust collects mostly in the first field. But when we talk about the ashes in the similar hopper of different passes, parallel passes, so all the passes, let's say there are four passes in a 210 megawatt boiler, so all the first field should have a similar kind of dust collection, the volumes or weight. It can vary only when we have a different set of gas distribution between the casings. If one casing is having 20-meter cube, another is having 10-meter cube, another has 15-meter cube, so that means the total ash load to that particular ESP casing is less. So in many cases, we have seen the middle passes of the ESPs have higher gas collection and extreme passes have lower ash collection. If you look at the flow profile, you will see there are changes in the flow distributions. So that can be corrected very well by a flow studies.
Right. So regarding the PM emissions, so what is the minimum PM emission level that can be achieved?
I would say for premium PM emission can be achieved as low as less than 5 milligram or less when we go with the back filter. However, ESPs is very critical to achieve very low emissions. However, today ESPs can be designed for emission as low as 10 milligram or lower.
So the next question is, what is the reason only ESP is discussed for PM emission? How about bag filters?
Can you please repeat that? There was a disturbance. Sorry for that.
So the question is, what is the reason only ESP is discussed for PM emission control? What about bag filters?
Okay, when we talk about this ESPN backfilter in perspective of power plants, you can see on the screen ESP has very many advantages. Number one is it does not hinder you from load limitation because it has a very low pressure drop across ESP. The reason is only if the emission is high and we have to stop the plant due to not meeting the emission, that's the only one which will hinder you from reducing the load or stopping the plant. The ESP does not limit your production mostly, and it is easy to maintain. The maintenance cost is low. For back filter, the challenges are different. That it has a high cost. Number two is high maintenance cost and running cost because with the coal ashes which are very high risk even erosive. Normally the back life is varies from 2 to 3 years. So every 2 to 3 years you have to spend millions of rupees to change the backs, as well as the running cost for ID fan due to a higher pressure of across back filter which is around 200 adds to the cost.
Mhm.
The only advantage or the better advantage is that it can give you positive emission, which means it can give you lower emissions, but with a higher maintenance cost and operational cost. So that's the difference. And it's the choice. How do we, which equipment we want to go with?
Okay. So how to ensure a complete evacuation of ash from last few fields of hopper where ash accumulation is less?
As yes, in the last few hours, the ash accumulation is less, and so there are two things. One is we normally do very less wrapping in the last fill in the ESPs, which means maybe in a day, in a shift, or something like that, so that there are layer deposited and then that goes into the hopper. For the last hoppers, yeah, there could be challenges because the ash evacuation timeline should be very high, once in a day or once in a 2 3 days many times, and that can compact the ashes in the hopper. So there are certain ways like keep the hoppers quite heated above 120 140 degrees centigrade. You can have the fluidizing air in the hoppers, and sometimes if you need we can have a vibrators in the hoppers to keep the ash flowability when they are discharged. So there are certain challenges I know in the uh, evacuation of large fields where the accumulation time is quite long. So these are from the factors externally we can help to keep the mobility of the ash.
Okay. Uh, so what is the difference between high resistive and low resistive dust? Which one is difficult to remove in ESP?
Okay. High resistive dust and difference between high resistive and low resistive dust is uh, say let's say we have coal ash. Even in coal, we have high resistivity and low resistivity. When we talk about lignite coal, which has high sulfur, then it is low resistive. Reason being, the difference between the resistivity for the particle is the dust which is able to charge quickly and easily is low resistive. The dust which we are not able to charge quickly or easily, it is high resistive. That depends on the nature of the dust. Additionally, on the flue gas parameter like temperature and electrical characteristics. But for example, if we talk about lignite coal, it has high sulfur, then it is low resistive because it can be ionized easily when goes into the ESP gas stream. With the coal, with the bituminous coal, if you have a low sulfur coal, but in the coal ash analysis, there are certain particulates, some elements like sodium oxide, potassium oxide, and iron oxide. These are three prominent components which directly determines the resistivity of the ash and impact the size of the ESP drastically as well as performance of the ESP drastically. So all this varies from coal to coal. With the low ratio, typically are from pulp and paper plants, soda recovery boiler, cement plants, moderate resistive, steel plant, low and moderate resistive, copper and zinc smelters, low and moderate resistive, which can be easily charged.
Mhm. Okay. Mr. Agarwal, we have some more questions there, but due to paucity of time, we won't be able to take them. I will request you to please share your email address with the audience so that they can email their questions to you directly.